Hey y'all, it's me, your bud, your guy, Mr. Thedorius Rex, coming at you with Lesson 79, finding equivalent fractions by multiplying by 1. So this is actually a pretty fun little thing. It takes a second to understand exactly what you're doing, but this is going to be pivotal. This is key, okay? So you can, a number multiplied by itself, by 1, is just itself always, remember? So remember, multiplication is just addition faster. If I have 5 times 2, it's just really 5 plus 5. If I have 5 times 3, it really is just 5 plus 5 plus 5. Okay, they're the exact same thing. Multiplication is just a way to express addition faster. But if I have addition, if I have 5 times 1, okay, well, it's no addition at all. It's just 5. There's 1 5. Okay, so really, I mean, you would think it's useless, right? You wouldn't think there'd be anything there at all. Except what we're going to do with it is actually pretty ingenious. It's pretty interesting. So we call it equivalent fractions is what we're trying to find. So if I have the fraction 1/2, I can multiply it by 1, except this one looks really weird. It says 2 over 2. Well, how many times does 2 go into 2? Goes into it 1 time. Okay? 2 over 2, or 3 over 3, or 4 over 4, these are all the same exact fraction. These fractions are all 1. Okay? Each one of these fractions is just a different way of writing the number 1. Okay? If I have a circle and I've cut it into 6 parts, okay, but I have the whole thing, I have 6 of those 6 parts, then I have 1 whole pizza or 1 whole pie. Okay? So what we're really doing here, if I had, let's take a similar thing. If I have 1/3 here, okay, I have it split into thirds, and I only have 1 of those, okay, that's 1/3. But if I go ahead and I cut it a second time, I cut it here, I cut it here, and I cut it here, okay, well, now it's the same as this, right? So now I have 2/6, okay? These are the exact same fraction. The shaded amount, what I have, has not changed. I've just cut it into different parts, okay? But the amount you have has not changed. You've just changed the form, okay? So that's all we're doing here is we're changing the form, but the number itself is always going to be the same. So if I am timesing both by 5, I get this. If I times both by 6, I get this. 7, 8, 9, 10, okay? These are all the same fraction. 5 is half of 10, 6 is half of 12, 7 is half of 14, so on and so forth. Okay? So what we do here, the way I like to do this is I say, okay, 4 times what equals 8? Well, 4 times 2 equals 8. Okay? So now I take 2 times 3, okay, and that will give me 6. So over here, if 3 times 4 is 12, then 2 times 4 is going to give me 8. Okay? And that's what we're going to do over and over again. Okay? This is when we are adding and subtracting fractions, you have, and that's the next part here, spoiler alert, is you can only add and subtract fractions when their bottom is the same, when they're in the same form. So we're just going to learn how to change forms so that you can add and subtract them. Okay. All right. See, now you can add and subtract these two numbers. Okay. First, I took 1/3, multiplied both sides by 4 to get 4/12. I took 1/4 and multiplied them both by 3 to get to 3/12. Now they're both in the exact same form. and I can add them together to get my new fraction. Okay. It's a little complicated. It's a little odd sometimes. Sometimes you have to do some really big things, okay, in order to get your answer. So over here, they're multiplying both of these by 25 so that they can turn the bottom number into 100. Whenever the bottom number is 100, okay, you'll use this, and I hope they don't ask you to do this too soon because it's kind of complicated for some things. But whenever the bottom number is 100, okay, that tells you the decimal is 0.75, and that tells you the percentage is 75%. Okay, so having the bottom number be 100, the denominator, that's very helpful. Okay, I'm going to go ahead and do this lesson practice for you in a second. I do want you to try it on your own first without me. I want to go over the written practice and what I expect of you guys. What I'd like you guys to do is 10 through 17 all. Alright, so go ahead and give it a start without me, but I will be hot on your tails doing it, and you can come back here and do it if you need help. Alright, 4 times 3, so 12. 4 times what equals 12, and that's 3. 3 times 3 equals 9. So 3 times what equals 6? Well, that's 2. 3 times 6 is 2. 2 times 2 is 4. 3 times what is 12? That's 4. 4 times what equals 100? Well, they showed you that up here, so that one is nice and easy. So 25 over 25. Okay. Also, it helps because 1 times 25 is 25. So yeah. Okay, so here we're actually having to do two bits of math. Okay. 3 times what equals 9? Well, 3 times 3 equals 9. So 1 times 3 is going to be 3/9. 3 times what equals 5? That's going to be 5. 2 times 5 is going to be 10. 3 times what equals 10? That's 2. Or 5 times 2 is 10. 3 times 2 is going to be 6. Okay? So again, if I have a guy here, a square, okay, and it's kind of 1, 2, 3, 4, 5 bits, okay, and I have 3 of these bits, 1, 2, 3, but now I cut it into 6, okay, so now I have 6/10. I haven't changed how much I have. I still have the same, okay. I had 3/5, and that turned into 6/10, but the actual shaded bit doesn't change, okay. Write a fraction equal to 1/2 that has a denominator of 6. Boom. So whatever is 6, right? 1/2 times 3 equals 6. 3 over 3. Then write a fraction equal to 1/3 that has a denominator of 6. Okay. So 1/3 equals 6. So 3 times 2 equals 6. So 1 times 2 is 2/6. Now I have to add them together. Okay, and I just add the top number. So I have 2 6 plus 3 6 equals 2 plus 3 is 5. The bottom number does not change, and we get 5/6. Write 3/5 as a fraction with a denominator of 100. Okay, so 5 goes into 100 how many times? What times 5 equals 100? It's going to be 20. So I'm going to multiply this by 20 over 20, or a 1. So 3/5. 3 times 20 is 60. Okay, 60 over 100. And then that turns into 60%. All right, that's the work. Have a good one, my dudes.